Yeah, as you said, it's how to prevent security afterthought syndrome. I'm not in academia teaching currently, but security and computer science education is something I'm very personally passionate about. And this talk is about how to change how we teach computer science in general as a way of changing how people think about security. And I use environmental engineering as an example of how this could work because they've had similar successes there. But anyways, on to the talk. So the security afterthought syndrome, I don't know if anyone else has a snappy name for this, but this is what I call it, the thing where no one thinks about security until it's a problem. And you know, you're all security professionals, so you all know what this is. And it's just, we get all these avoidable bugs that would have been easy things to fix in the design stages, but that become difficult or impossible to fix later on. Just like in the previous Chromecast talk, he was saying, well, at this stage, there's really nothing to do about it. You know, there's lots of attempts by educators to try and figure out how to redress this general attitude, but in order to fix a problem, you need to understand where it comes from. If you don't understand the source and what the underlying cause of a problem is, you're just addressing symptoms. So the first question is, why is security an afterthought? And the security is an afterthought because we teach it that way. It's usually a separate elective topic that students take if they're interested in it when they get to their junior or senior year, which is good for creating specialists, but it's not how you get your average computer science undergraduate to have the security underpinnings they need for their work. And by then, everybody already has all their bad patterns and bad habits, and changing those after they've been set is way harder than teaching good habits from the get-go. So then you're fighting an uphill battle. Students really don't see meaningful security content in the average undergraduate college program until the end of their undergraduate careers, or just not at all. You know, so of course it's an afterthought. So first, I've made some assertions about how computer science and security are taught, and they're pretty strong assertions, so I wanted some data to back that up because you know, it was my gut feeling and it was what I knew based on my personal experience, but I'm a scientist and I like to have data. So I surveyed 100 different computer science department heads. I got 33 responses, which was a fabulous response rate. I was thrilled. And I asked them about how they prioritize security and integrate it into their curriculum. I mean, I asked them about some other things too, because you don't want them to know that you're specifically interested in security, because then, oh yes, of course we care about security. But, and a friend of mine who knows how to do these things lent me the Psychology of Survey Response, which was very helpful in figuring out how to ask questions without being misleading or without tipping your hand too much about what you were actually trying to get out of it. So if you need to collect any data like that yourself, I highly recommend it. But without further ado, the data. So the first question I wanted to answer was, how is security ranked with regards to other subjects? So I had 10 different undergraduate core subjects, and I asked the professors to pick the 5 that they viewed as the most important to include in the undergraduate curriculum. And some of you are already reacting to it. As you can see, I've got these ranked from most popular to least, and we've got algorithms and data structures came in at first, which is not surprising. Then software design, operating systems, programming languages, and security is number 9, and with only compilers after it. It was a terrible showing. And, you know, I mean, maybe not that surprising, but, oh, yeah. What? You were right in topics, you know. Yeah, it was not a good day for security. But, and then the second question was gathering similar data, but asking it differently. I gave them 6 topics and had them order them in terms of importance, with 1 being most important, 6 being least. And again, algorithms and data structures is clearly number 1. and software design is clearly number 2, almost unanimously. The rest of it's a bit of a muddle, but security is ranked 5th more often than anything else. And then the same data a different way, I'm just showing the mean importance rankings, and again you can see security is 5th, its mean ranking was 4.7. Okay, and then another question is how integrated is security into the general curriculum? Like if people don't seek out that specific security course, how likely are they to see any security content at all? And so here I had them rate their curriculum with 1 being security is totally separate, 5 being security is totally integrated. And you can see out of the 33 responses, we've got 12 totally separates, 10 mostly separates, and only 2 totally integrateds. So, you know, for the most part, undergraduates really aren't seeing security content. And then my last question was how applied versus theoretical is that security content? So I have along the x-axis the integration ratings from the previous question. And then for multiple topics, I asked them to rate things from 1 to 5, where 1 was totally theoretical and 5 was totally applied. And so the answers were mostly 2s to 4s, because nobody teaches something that's totally one or the other. But what you can see here is it gets more applied as y increases. So as things get more integrated, they become more theoretical. In other words, when you start integrating security into the general curriculum, the security content gets dumbed down. So, and overall, security was the 2nd most theoretical topic. The only thing that was more theory was algorithms. So, none of this is great, but none of it's that surprising either. Where does this leave us? Is that security is not highly prioritized. And when it is integrated into the curriculum, which is rare, it's usually in a more theoretical, abstract form. So, you know, that's why we're in the state we are in general. This just is a natural extension of how we teach the subject. And like I said before, we have these separate security classes for students specifically interested in security. But one, you're preaching to the choir. These are people who chose to take that class. They already value security to some extent or another. And those are your future experts. That's not your average graduate, and that's not the people who keep putting out the terribly buggy stuff that causes all these problems. So what we need is to integrate security into all these other courses. Security is a natural facet of pretty much every computer science topic, and it should be taught that way. This sounds like a pretty tall order, so before I go too much further into it, why do I think this is worth it, and why do I think it'll work? Because it worked in environmental engineering. So, at first this seems like a pretty big left turn, but environmental engineering and security actually have really similar origins as fields. In both cases, we had a lot of problems of a particular class, and then we made a field to address those problems. So the fields themselves are, to some extent or another, afterthoughts. You know, it was just the whole, oh, this is all made of poison, we should figure out how to deal with that, you know. So the afterthought problem is just part of the natural growing pains of squeezing this new field into how we think about the overall subjects. But environmental engineering's been around longer, so they've made more headway against their own afterthought problem than we have, and we can try and make use of that and speed our integration up. The most interesting development there recently is that the Accreditation Board for Engineering and Technology added a one-line change to their requirements for accredited mechanical engineering and chemical engineering and all sorts of engineering fields, so that now undergraduates need to come out with the ability to evaluate their designs for environmental impact. And it really is a one-sentence change, but in terms of curriculum design, it's a really big deal, and people had to scramble a little bit to deal with this. But it makes sense because, you know, just like with security, if all those engineers are totally unaware of the environmental aspects of design, then they're going to keep putting out things that are causing all sorts of problems, and then the experts are just dealing with those messes instead of dealing with problems that are actually worthy of them. And so they had to change all these programs to deal with the new accreditation board requirements. And it's actually really changing attitudes. I'm friends with an environmental engineer who was telling me that over the years he gets contacted periodically by students with questions about his previous publications, and it used to be that all of those people were environmental engineer students, but now half the time they're environmental engineering students, but sometimes they're mechanical engineers or chemical engineers or even MBAs. And it's not that they're doing some special program or a minor or something like that. It's just part of their normal coursework. And, you know, he's thrilled by this. The other reason why attitudes are changing there is because of legislation. There's more and more laws coming out, I guess maybe more in the EU than here, but we're catching up, you know, legislating environmental aspects of manufacturing. You know, what are you allowed to put in your batteries and things like that. And it's becoming more of a liability for companies to hire engineers who don't know how to evaluate their designs for these sorts of issues, because then they might run afoul of these laws and, you know, run into big expenses later. And right now there isn't an equivalent to this in computer science, but we shouldn't assume that's always going to be the case, especially the longer security becomes the huge problem that it is, the more likely somebody's going to try regulation as a remediation tactic. And, you know, so and as environmental design becomes more of a priority for employers, it becomes more of a priority for educators, because, you know, you want your students to be able to get jobs. And then the other thing is that this isn't even really true just for engineering. One of my cousins is studying industrial design, and we went to go see this open house they were doing where all the students showed the projects they'd made for this class. And when they were all running through their checklist of the design features, one of the things all of them mentioned was how sustainable was it, how much waste was produced, how, you know, what is the environmental impact of manufacturing this thing. And it's not like the class was focused on that, it's just they've been taught that's something you have to think about in the design and prototype stage, because it's too expensive to fix those problems later. And, you know, they don't come to that conclusion on their own, it's just because it's taught that way. And that's what we need in computer security. We need educators to make it clear to students that this is a priority, and, you know, that they learn the right habits earlier rather than later. And it's totally doable. But is anyone doing it yet? As far as I know, no. I mean, if you have any examples of this where people are teaching a fully integrated curriculum, then I'd love to hear about it, and we can do that in the questions. But I wasn't able to find anything myself. And, you know, because I hadn't seen this idea presented anywhere else, that's part of why I'm here doing this. And I also, when I couldn't find any curriculums that were actively taught doing this, I looked for, you know, policy documents or, you know, reports or curriculum guidelines and whatnot. And the closest thing I was able to find so far was the ACM CS 2013 guideline. So ACM puts out a curriculum guideline every few years, the most recent one being the 2013. And this was actually the first year that they had a security knowledge area, which is pretty embarrassing, although at least they got there. And when they introduced it, they know that undergraduates already have to take a lot of courses, and they didn't want to add to that number, so they decided the best way to get that security content in there was to integrate it into all the other classes. So it was the most integrated curriculum I've seen so far, and it wasn't bad, although they were integrating it for the not maybe the right reasons. Like, they didn't understand why integration is a goal in and of itself. So there's a few spots where things are included in a familiarity level rather than usage, and students need to use things in order to understand them. And a few cases where things were at a, like, labeled as elective rather than core that really should be core skills. So it's the best thing I've seen so far, but still needs work. And the biggest issue I had with it, not to beat it up too much, was that in the software engineering section, they described secure software engineering as a non-functional requirement. And that is a real problem. I mean, it's a one word, you know, so maybe you'd say I'm being too picky, but well, maybe not you guys, but but that gets to the heart of the whole problem, which is this notion that we teach our students that if they give it this number and it outputs that one, then the code works. And like that, for all their homeworks, that's how it's evaluated. We give it certain inputs. If it gives the right outputs, then you get the green check mark. And what you need to do is also have you know, robustness and security as required features on all those homeworks. You know, the notion that they need to learn that code only works if it also is robust and doesn't put its users at risk. That without those features, it doesn't get the green check mark. Anyways, so moving on from that. So when I talk about this initially, it sounds like a redesign of the whole curriculum, which is pretty intimidating. But it doesn't always have to be huge changes. It can just be little tweaks to things. So I took a couple homework assignments from classes that are actively taught. This first one's from UC San Diego. And it's from a networking class, so they're talking about BGP. And they give them this network diagram and ask them various questions that are supposed to demonstrate the students' understanding of how BGP works. You know, so if E wanted to get to B, what path would it take? Or if F wanted to get to C, what path would it take? Or if AS3 doesn't want its traffic to traverse AS4, how would they do that just using BGP? So it's just things that illustrate the knowledge of the features of BGP. What's missing is the knowledge of the limits of BGP or the knowledge of the weaknesses of BGP. Because the whole notion that we, for every tool we provide them, only teach them about its positive aspects is frankly ridiculous. So you should also ask questions about traffic hijacking. You know, if AS1 wants to hijack traffic that's going to AS7, what would they advertise? Or how can you make use of various well-meaning but misguided features of the tool? You know, like this is something that students need to think about so that they just learn this particular mode of thought. And, you know, the first step to being able to evaluate the security impacts of their own designs is to be able to evaluate that in previous designs. It needs to be a skill they build up, and this is how you would do that. Then my second example problem is from an algorithms class, and this was just a really simple hash table problem where they're given a mod 13 hash function to apply to letters of the alphabet. And here, you don't even really have to change the question at all because they were already asking about worst case runtimes. It's just that when we talk about worst case runtimes in algorithms classes, we present it as the thing that happens if you had really bad luck. And, you know, bad luck can be manufactured, and that's something that they need to understand. You know, a worst case runtime isn't just your bad day, it's also an attack vector. And, you know, that's the thing that, and so it's the same question, you just need to word it differently. You know, you need to present it as, if an attacker wanted to slow operations down, what's the longest runtime their denial of service attack could force? And how would you try to avoid that? And, you know, it's just getting them to think about the exact same things, but with a different spin that puts them in a different mindset. Okay, so what needs to happen? One, security needs to be a part of every course because every computer science topic has security implications and security aspects to it. And taking those all out into some separate course is great, but it also needs to be there in the basics. And introducing a concept once isn't enough. You know, just saying, oh, we talked about that in that lecture, not good enough. You need to repeat things frequently in order for them to become reflex. And so every time you have a homework where students are programming, you know, security and robustness need to be on the required checklist. And every time you're discussing how a protocol works, you need to talk about its weaknesses and how it doesn't work. And every time you talk about worst case runtimes, you need to talk about how those can be manufactured and what things can you do to prevent that from being possible. You know, it's just about repetition and making sure that these things are drilled into the point where they just think about it by default. So, and the other thing is that this needs to be applied. You need to do it in the homework. It needs to be something that they've used and worked with, because otherwise it's just not going to sink in. The best way to learn how something works is to learn how to break it. So, you know, this isn't even just about learning security, it's about them better learning about the things they're going to end up using later. You know, it improves their general understanding, not just their security understanding. And finally, this was actually something that was suggested to me by Ed Felton, because they do this in one of the advanced programming classes over at Princeton. But, and it's great, which is that anytime you have homework assignments that involve programming, whether it's security related or not, you should subject it to fuzzing and other automated security attacks, and then the students lose points if they don't handle it well. You know, the students learn the best lesson through pain, at least a little bit. And, you know, if there aren't any penalties for failing at security in school, then they're not going to think there's any penalties for doing it badly when they leave school. Okay, so, and once again, it's important that it's application, not just theory. I mean, conceptual understanding is a great first step, but what makes something real to a student is working with it and using it, so it has to be put into practice. And as security becomes a bigger part of the curriculum, it's important to also teach people how to do security research legally and safely. Like people who already have good security programs create sandboxes for their students to play around in. And that's great, but you also need to make sure that your students know what makes that sandbox different from the real world. What went into making it so they can make their own when they're not in your careful care anymore. And, you know, just understanding that it's a manufactured environment. Because, you know, intellectual curiosity is great and to be encouraged, but if people don't understand that that sandbox isn't the same as the real world, then sometimes they come out with a kind of, hey, what does this button do mentality that can get them into trouble later. And, you know, the part of being a good educator is making sure your students are safe. But anyways, it's a little bit of a diversion, but I think an important one. Okay, so tweaking the core curriculum can have a big impact if we do it right and if we understand what end goal we're working towards. And folding security into the existing courses means you don't need to lose any other topics to make room for it, and it'll give the students a better understanding of those core topics. The way people are first taught to think about something is how they'll likely always think about it. It's really hard to change thought patterns after they've been set. And so anything that just tries to course correct and add security in after all those behaviors and bad patterns are there is going to be a losing battle. It's just way too much work and you're fighting against too much. So the only way to make security integral in people's work is to make it integral in their education. So back to that accreditation board thing, this one change in the curriculum requirements made a really big change in how this stuff is taught and how educators think about the topics. And it would just need to be a one-line change for computer science. Just computer science graduates must be able to evaluate the security of their designs. And just imagine if we had that, how much better this entire field would be. You'd find new things to do. I mean, you know, not everyone's going to always get it right, but at least they would be trying. And anyways, thanks to my friend Neil for lending me that Psychology of Survey Response book. It was great. And thank you to all the professors who answered my survey, because it was the end of the semester and they did not have to do that. And on to questions.
Thank you. Wonderful talk.
Oh, great. Thanks.
And I've been waiting to hear this stuff for years. One of the problems is that engineers have accreditation boards. They have licenses.
Mm-hmm.
There is no such comparison for people who work with computers. You can pick up anybody off the street who learned programming from the back of a 1993 Pascal book or something, and programming is the kind of thing that you can pick up pretty easily and actually get halfway decent results until long before the problems turn up. So have you thought about how we could apply these things in a way that will actually stick and stick to not just the people who are accredited, but everybody else who's programming, because there's plenty of people programming there without degrees in CS or anything else computer related.
I believe the first step, if we don't have that accreditation board boost to get people motivated, is to find some professors who actually do understand security and get them working together to develop a new curriculum, to update things, and then get buy-in from industry reps that have big hiring power by getting their seal of approval that we hire students from these programs before we hire students from the other programs. It's something where it has to have money attached, because that's why people do anything.
So funny you should pick the worst example of namely BGP.
Well, it's an easy target.
Right. Yes.
And sort of a family habit.
Well, having taught BGP and pointed out the security thing is yes, some of it's a good. So a fundamental problem with this changing the curriculum, and I don't have an answer, is how do you get the people who are doing the teaching, right, to especially in some of the better schools, where you're not rewarded for teaching well, you're rewarded for how much grant money you bring in. Yes. To implement these changes. So, those of us who have worked with security and teach occasionally do this sort of thing. But
I do know that motivating any sort of major change with people with tenure can be a tricky proposition. And if you have any suggestions, they're welcome. But I think one thing is to get some grant money out there for doing this. There are organizations that would, if the proposal is written right, give some grants for doing this sort of redesign. And then, I don't know, my best bet for the other thing, past that, is just to make it so that the students coming from these programs get hired, to get buy-in from industry. But I don't know, do you have any other suggestions?
Well, that's actually not a very good incentive, because there is such a lack of qualified individuals to hire already, that we tend to overlook things like, they didn't take a security course. Well, okay, they learn it.
Well, and the other thing is that while we don't have the sort of legislation that they have for environmental engineering now, there aren't laws that get a company in trouble if they fail miserably in their implementation. The longer things go the way they are, the more likely regulation's going to happen. So at some point, it might just be something that people can't ignore anymore.
I'm not saying we shouldn't do it. Well, of course, we should be doing it.
Yeah.
Just trying to figure out how to.
Yeah, and that's something I'm actively thinking on and trying to come up with approaches for. So any input is welcome, but yeah, it is a little hard to motivate. So I think the first step is just to get people who are enlightened enough to be interested going as an example, you know, and then work from there. You know, you have to start somewhere.
Thanks.
Hey.
So as we're talking about some of this stuff and how it's important to like start off with this mindset, I just had really not a question, but just a comment. I couldn't help but notice the similarities between this type of mindset of thinking about security and the mathematical proof concept. Because, you know, if you think about like, okay, would you hire a graduate from a math school that all they had to do was figure out the right answer for a problem, but not say, here's why it's correct, here's why there aren't any holes in it, here's why it's not broken.
Right.
And that might be a useful metaphor in trying to pitch this to people, because proofs are something that like you start out learning them in like geometry or something like that in 7th grade, and like they're just a completely different concept for you to wrap your mind around. And then over time you get used to that mindset, and you get drilled into you that this is the way that you have to think about things. And I think that there's a lot of similarities there.
Yeah.
So,
The similarity to mathematical proofs works on a couple levels, also because they don't have you prove something just once. They make you do it over and over again until you learn the patterns of it and you learn the sense for what direction you should probably go in initially. And, you know, part of that is just doing it enough to build up that instinct for it. And that's something that's needed in security, having, you know, done enough evaluations that you start to get that just internal sense of where you should probably start. And that's something that you can't just teach in one lecture. It has to be taught by doing it lots of times. And yeah, so the mathematical proof analogy holds up very well.
cool. And the only other thing I just wanted to comment on is you mentioned having people have like a place that they can do this, and I think that's really important. Like, for example, you know, at RPI we had operating systems teacher that taught us about fork bombs, but he said, hey, don't go and execute these on the RCS servers because they'll get mad at me for telling you guys. Giving people a place that they can experiment free of legal worries, free of worries that they're going to get in trouble for it, and say, hey, you know, here I've set up this process running on the server, see if you can, you know, inject SQL or something like that into it.
Oh,
I
yeah.
think is definitely.
And
good
I have a
exercise.
couple personal funny stories from cases where students had that safe environment but missed the don't do this at home part of the lecture, which is also important. Did you have a question?
Well, I have a comment. As I was watching you talk, I was kind of thinking I'm a little pessimistic about the state of the industry, because I think the priority for a lot of working programmers is like just get something working, get something sellable, get something that your boss will get off your back about, and then, you know, at the end worry about security if there's any extra budget,
But
and there
that's-
never is.
Yeah, and I understand that schedule crunches and everything do lead to a lot of sloppy habits, but the way to address that is to change their internal definition of what does working mean. You know, to make it so that their does it working question isn't yes until they've actually considered the security of their design. And, you know, that's the part where I think education comes in. I mean, I think they just need to redefine that word. And yeah, I mean,
I agree.
employers need to also, which is also a thing. But yeah.
Yeah, and to kind of underscore your own point, if you teach somebody this from day one, and they're going to stick with it for their life, then you know, we'll get better quality software, and everybody will be happier.
Yeah, I mean, it's
So
just.
I'm glad that you're thinking about this, because I don't have the time.
Well, I'm doing my best.
Thanks.
Thank you.
Well, I also want to thank you for this. This is very good. And I'm teaching at college, and I'm living with this all the time.
Uh-huh.
And Dan Kaminsky said something about 2 years ago at a conference that really caught my attention. He said, go to developer cons and talk to those guys about security. So I started doing that, and I was horrified. They just have no clue at all. They're up there afterwards telling me that one round of MD5 is fine for a password, and what am I talking about? And the talk I just submitted said, there is nothing in this talk that is not 15 years old, and they approved it, and they're flocking in. And I said, it's madness.
Yeah.
And I think this is what's going to change it. I mean, real convincing presentations like this. The curriculum stuff might be good too. I'm not my field, but I'm very impressed by this. And I see there's another thing that I've seen happen because of this. The four-year colleges have no security in undergraduate at all. They think it's a master's curriculum. So the effect is my students refuse to get four-year degrees. They cannot see any reason after a couple of classes, certifications, to not get in the field and get a job and go get a degree, which is as valuable for them as Latin. And what I'm seeing is, I don't understand. I can't convince them to get a four-year degree because I no longer believe it myself.
Yeah.
I mean, I got a PhD, but as far as I can tell, there is no use for a four-year degree in the field of security.
Well,
it's just a waste of your time. What do you
And
think?
there's so much out there to learn, so we need to make a curriculum that's worth their time. You know,
Yes.
wasting people's time is just, it's not right, and we need to make it worthy of being taught.
Yeah, but there's something very strange here because the four-year degree has totally failed to notice that security is a problem. And how can anyone fail to miss that? Right? How can they miss that? I'm confused. They've let themselves become obsolete.
Well,
It's very
and
strange.
the way people learn things is the way they then teach them, so
Yeah.
there's a certain amount of momentum. But whenever I was describing what my talk was about to people who weren't computer scientists, their first reaction was always, you mean they don't do that already? Like, it's always they're just shocked, and then they're, oh, well, I guess that's why I had to get a new Target credit card. You know, it's just
No, you're absolutely right on the money. They do what they were told to in the book. They do what got them an A, and it's another generation of the same crap. We can all
Right,
hack into.
and of course they're going to do what we train them to do. I mean, it's just how it works.
Well, thank you very much.
Thank you. Hi.
Hello. Oh, okay. So, good talk, first of all.
Thanks.
So this is not so much a question as a comment, but this is something I sort of thought about a decent amount. And part of it is just like, well, how do you like really effectively teach security, even once it becomes a priority? Because just by the nature of the subject, it's just a world of unknowns. But what I've sort of found in my experience is that there's a decent amount of overlap in terms of like just defensive programming and good programming habits, unrelated to security, that while improved security also improve the overall robustness and fault tolerance of the application.
Oh, yeah.
If you are, when you're accepting user input, you think like not just because of security, but in terms of just general, this is how to make the software as robust and fault tolerant as possible.
Right, because people
I will
are
handle
going to be
all
using
cases.
this, and they do
Yeah.
really bizarre things.
So there's, it's almost doesn't exist like as this separate, like you say, as an afterthought, where you have to like, well, I've written it and now I have to evaluate it for security. Because if you're at that point, like maybe you just wrote kind of shitty code. And if you just, because it feels like in part of writing code that is robust and really handles all of the cases that you could really expect it, you can almost frame it in a different way, not even in terms of security, but in terms of good defensive programming habits.
Yeah.
And I feel like that, in addition to giving people, like if they're learning to write software, the tools to write secure software, they're also just learning to write better software. So it's almost, it's the same thing, but sort of framed differently. But like I said, not really a question, but
Thanks.
Reliability is a subset. Security is a
That's
subset
true.
of reliability, really.
well, that's
Yeah.
where PCI and companies that have to care about security.
Hi, I was wondering, of the 33 respondents, have you had a chance to share the data with them, and have they made any comments back, like
Well,
apologies?
actually, part of how I got people to give me answers was that I said when I was done, I would send them the anonymized results so that they would have some sort of reason to respond to me. So I did send them all my responses, but that includes all the other questions I had that weren't security related. So I haven't told them why I was collecting the data or what the talk was. I was thinking maybe I'd send them a link now that it's out there. And yeah, I don't know what the responses will be, but hopefully not too rude.
Do you plan on sharing any responses? I mean, anonymized, of course, but
Oh, I don't know. I mean, I don't know what I would gain from that in terms of, I don't think it would make any friends or get me any extra buy-in from anybody, but it would probably piss somebody off that I need to deal with later.
Fair enough. Thank you.
But, yeah.
Hi, good talk.
Thanks.
So I'm a architect for enterprise software. One of the things that we've done is we've built our own training. It's pretty thorough, mainly because it doesn't seem to matter what level of education people have coming out of computer science. It's
Yeah.
never the right stuff. And it's really usually around real world application. One of the things I noticed, which we had the same problem in our area, I'm from the Cleveland, Ohio area, is there's always this misconception that non-functional requirements is a bad thing. It's really just a category of requirements. So functional meaning that it applies to the business of the software. So like we build financial software, so it, functional requirements would relate to that financial stuff. So what we've done is we've been trying to be, some of the guys I work with, we've been part of this effort to try to rebrand it as quality factors, because I think it calls out a little bit more what it's for. So when you talk about like robustness or scalability or security and the other, all those other topics, we brand them as quality factors. And I think, I would encourage anyone out there to do the same thing, because I think it makes it a little bit more clear that they're definitely factors of quality that apply to the software.
Yeah, I mean, describing it as non-functional makes it sound optional.
It sounds negative.
Yeah.
But they're still requirements, right? It's just non-functional requirements. Functional meaning applies to that business specifically. Non-functional meaning quality factor. But anyway,
Yeah, it's a good tip.
more of a comment.
Hi again.
Questions. I'm back again. So I just had one more thing that as I'm thinking about this, I'm trying to think of like how I can help you sell, how do you help sell this? How do you make it stick?
Yeah.
So one thing is, as people are talking about security and how they think about security, I couldn't help but think of like all these other things that are similar. So it pisses me off that I went through a 4-year degree in computer science and nobody taught me about test first design. No one. I didn't write a single unit test in 4 years of computer science degree at a new Ivy School, at RBIS.
Right.
So every day, I work for IRU. Every day I write code and I don't write unit tests and I feel bad about it. Every day I write code and I don't think about security and I don't feel bad about it. That's, I think, where we need to change. Like, I'm aware of that I should be doing code reviews, I should be doing TDD, I should be doing all these things, but security has, through one way or not, it hasn't made its way into my psyche as like, this is one of these things that I need to be doing. So I think we need to rewrite computer science curriculum to teach test-driven design, to teach peer code review, to teach all these things, and I think like security is just, it's one of the major factors that needs to make in there. But I think a program that attempts to address some of these other places that the stuff that we're being taught in schools doesn't represent what you really need to do in the real world to build a quality product. I think maybe putting security in there with these other things would help too.
One of the open-ended question at the end of the survey was one where I let people talk about what topics did they think were over or underrepresented in curriculums today. And a few people said that what they thought it was missing was the class that gives students the same experience they're going to have in the workforce, the dealing with customers and doing the whole code development cycle. Of course, the same number of people exactly said that they thought that curriculums were getting too applied and needed to get back to including more of the theory and fundamentals. So, a couple of different schools of thought there. But it is something that was already on a few of their minds. They just didn't necessarily include security in the list, like you were saying.
You said, like, okay, if I have the same functional requirements, but you give me an extra time to do it, I'm probably going to, and I do a test, I'm probably not going to say, I'm going to spend an extra time
Yeah.
to do it. I feel like people start thinking about it.
Did you have a question?
Yeah. First of all, that was a great talk.
Thanks.
I really enjoyed it. It seems obvious from listening to you that security needs to be a topic that is addressed in CS curriculums from day one. And I absolutely agree with it. what I'm wondering about is, it seems like an easier topic to address as the curriculum gets more advanced. But in the intro courses, it seems like it's a little bit harder to integrate. I wondered if you had specific ideas on how to integrate it with, like, say, like a CS1 course.
Well, I mean, whatever technical content you're including, there's almost always a flip side to that coin. Like, just as you have to ramp up how technical the general CS content is, there have to be security components to it. I mean, even if it's just priming how they think about things so that they keep having that on their mental list of features, you know, that you keep mentioning security concepts enough that it becomes reflex that that's always part of that subject. You know, it's a little hard without specific examples, but you know, but I think it's just important that you just keep it on their minds enough that they can't forget about it. I mean, everyone had topics in school that got repeated so often that they were like, oh, they're mentioning this again. How many times are we gonna have to learn the same thing? And then later on, you realize, oh no, I actually learned that one. Like, you know, you know, as a student, you don't always understand why they keep beating that particular dead horse, but then later on. But I think it's just important to just keep mentioning it, even if you're not quite getting into the guts of things yet in that course.
Okay, great, thank you.
So, again, very good talk. Thank you for that. I'm with a company, we have around 800 developers. So I'm actually dealing with the problem of having non-students, so programmers with years of experience also doing the very same problems. You know, the bad habits evolve over time. And we also found that, for example, we use code scanners in some departments, and we can see when we get new employees by the number of bugs. It's directly related, and also this creates pain on the developer side. So if they have to fix, you know, annoying bugs, which are obviously non-functional bugs, but they have to fix it, and it creates pain, that changes the habits.
Yeah.
So it's more or less of a, you know, kicking asses the whole time, but it works. It works, and that's what I liked on your approach there, with the homeworks constantly checking for security problems.
Yeah.
Yes. Yeah. It's like I'm posting to a hack on Usenet. I've got to, like, basically, it was a good talk, and here's my OB hack, and by the way, here's my comment and question. That's a little older than most of the folks here. Environmental engineering wasn't mandated and put in until certain countries started to actually say we are not accepting goods and services, and it started to have a particular impact, and this goes towards incentives. Recently, there was a ruling, and I think this was EU, where somebody said the company was held liable because the passwords were not encrypted, and that liability became on the company rather than on the end users. So the question here is there an incentive plan where we can get this in place, as you mentioned, you know, kind of like out of the altruistic nature and getting the right professors, or is it a case where we're going to have to wait for mandates and policy to come in, and this will happen naturally?
I mean, eventually, if those sorts of mandates were in place, everyone would have to get whipped into shape, but it'd be nice to try to do what we can to get there without being embarrassed into it. I mean, nobody's really, as far as I know, tried this yet, so it would be nice to see if we can do it. And then if everyone's too resistant and we can't get it in there, at least they have something to go back to whenever they're like, oh shit, we need security now.
Yeah, I can get into that. I'm from the Netherlands, and the parliament there have been discussing enforcing this stuff, but
Yeah.
It's impossible to do. I mean, who's going to do it?
Yeah.
That's the whole issue. That's why they didn't do it anyway.
Well, and whenever they do try to write some security regulations or legislature, there's nothing saying they'll do it right, but, you know,
Yeah, the enforcing part is the biggest issue.
yeah.
Same thing happened in environmental engineering too. Push back on the process.
Yeah. There's lots of reasons why they're not doing it yet, but I think over time they'll end up just having to, if it doesn't get fixed some other way. You know, they'll just, at some point it'll become too expensive for them to keep letting it go, and they'll just try something. Whether it's the right something or not, I don't know, but. Oh, there's a hand over there, but why don't you go first since you're at the mic?
Sure, thanks. So I thought it was a great talk, and it's probably going to be my last talk of the night because I'm tired. Leave me on a good note. Why are you hopeful? Aside from the Princeton thing, what have you seen that's been a good example of how schools do these kinds of things?
Well, we've got several friends who are professors who try to do this in their little corners of the world. Actually, West Point has a surprisingly good security program, and one of the professors from over there was involved in getting what security content there is integrated into that ACM document. We've Alex Halderman over at University of Michigan and Matt Blaze over at UPenn have both expressed interest in that, and with names like that attached, we could actually really do something. So we need to, I don't know, get on them and try and get them to do something more than say nice things. But they have expressed interest in it, and they do try to teach these things in their little corners of academia. But any other positive examples that people want to point me to, I'd love to see, because it would be nice to gather together all those like-minded people, pool efforts. What was your question? I am married to him. Yes, I'm married to Mudge. Oh, okay, well. Mm-hmm. Mudge might have issues with that statement.
I don't endorse that. The reason why is the big problem is we still have absolutely no idea how to define security in any kind of quantifiable mechanism.
Well, and any effort to change how this curriculum gets designed would be, you'd have to quantify the success. So you'd have to, is my time up? Okay, so you'd have to do some, give the students some tests to take beforehand that show some particular level of security knowledge, and then after they've, the next class goes through with the new curriculum, you'd have to do something to show that you had quantifiable success with the redesign, or else nobody has any reason to fund you. Data's always good. I like data. But anyways, my time's up. So anyone else who wants to talk, we can do that elsewhere, so that the next talk can get going.
All right. So thanks for hanging in there, and keep your energy up. And we're going to be having a jam-packed schedule. So up next is when the web strikes back, fighting mass surveillance with open standards with Harry.
Okay, so I've just got two or three quick questions. I wasn't quite sure who the audience was. I had to sort of guess. I wasn't thinking about giving a particularly heavily technical talk, although we could go very technical into JavaScript and whatnot if people want to. I was going to start with sort of a broad overview. I'm Harry. I work for the W3C. I'm in the technology and society domain. And the W3C is a standards body. So we're one of the standards bodies that handles things like HTML. And we've been, of course, very much concerned over the state of what we call pervasive surveillance. And I just kind of want to give a quick update of all of the things that we were trying to do, along with our sister standards body, the Internet Engineering Task Force, who's actually, I think, doing a bit more, and also give a sort of roadmap for some of the things that we were hoping to do. Because, to be honest, as we all know, the web has lots and lots of problems. So we're going to just go through these sort of quickly. Sorry, I have to, how do I get my, there we go. How do I, sorry, it's Linux, and I can't, it's not, double screens, and I'm going to have to like hide some of it over here so I can move it. See if I can get that over. The slides aren't really necessary, but they could be. Oh, there we go. Okay, so I think the one thing that people often forget, so how many people have heard of the You Broke the Internet initiative? Right, so the internet's completely broken, and we should create a new one that's peer-to-peer and really nice and stuff. And I agree, that would be great. It would be great if we had a new internet which didn't have all of the legacy problems that we have with the internet and the web today. Unfortunately, we have millions, billions of people on the internet and web, and I don't know that many people on alternative systems right now, really. I mean, so Tor's huge, but you're still talking, 500,000, million sort of users, and we have many, many more people who use the ordinary internet. And I kind of feel like you have a sort of philosophy as a hacker. You can sort of say, I'm going to build something completely different, and me and my friends will use it, and maybe it'll take off. And that does work sometimes. That is actually how the web happened. And so it would be really cool if that happened. Or you could take another route and sort of say, we're going to look at the existing, effectively, mess we have today, and try to fix as much as we can. And so we're going to look at the latter path. And the fact of the matter is the internet and the web are actually, which is a bit of a miracle, they are open platforms insofar as that anyone, including random people over mailing lists, can effectively join a working group and contribute to the open standards that define the internet and web. And that's the sort of thing I like to remind people. The internet and web is not just software, it's not just hardware, it's actually defined on an abstract level of protocol. So some people, Morozov, for example, will sort of say, well, the internet doesn't really exist, you just have Facebook, you have all these different apps. Actually, there is effectively a fairly singular set of protocols that define these environments, right? So if something doesn't speak TCP/IP, it's not on the internet. If something's not speaking a version of HTTP in your eyes, it's not on the web. And people who don't understand that, to be honest, like Morozov, I think are idiots. We actually need to educate people about the importance of open standards. Because the fact of the matter is, part of the reason why we got in this mess today with pervasive surveillance is effectively the state of benign neglect that many people had as regards the architectural plumbing of the web and internet themselves. Very few people were taking active stewardship of these protocols and effectively leaving them to standards bodies which, to be honest, need your help. So that's why I'm giving this talk today, because we actually need more people who are really concerned about security, concerned about privacy, concerned about surveillance, concerned about freedom, to get involved into this process, because right now it's a lot of work and there's not enough people doing it. So, I just want to mention one thing. And also people say, well, things change really fast. But actually, to be frank, they don't. Most of the original concepts, in the web and the internet, they were around for, the second known the internet had something like a blog. It was envisioned by Douglas Engelbart in the 50s as a way to solve large-scale global problems. We have lots of problems, and we need a trusted and secure internet to solve those problems. However, and what people forget also, which I think really has to be emphasized, is how many people here have participated in an internet engineering task force working group? Well, not a single one. Is it that bad? Really? So, okay, it is that bad. Not a single person has ever emailed the IETF. Okay, so often people say, well, I just went to this talk at Black Hat, and TLS is such a disaster. Why is TLS such a disaster? Why don't browsers do better certificate pinning? What is certificate pinning? How can we make sure that when I talk to one HT server endpoint and I'm a client, I actually verify that connection? And we're using good crypto, and we don't have all sorts of problems that have become very more widely known today. And actually, what you discover is that the core fundamentals of the internet, such as TLS, are effectively ran by groups of volunteers. Somewhat self-selecting, some people working there for companies, and they're running an open, consensus-based process, which is sort of crazy if you think about it. So it's a global consensus-based process, and that effectively anyone, particularly with the IETF, can join. And this comes from the unique history of the internet, as essentially it was a research project, and basically graduate students, got involved, and when they were defining the protocols of the software, because the military and the research units only paid for the hardware, they found what were called RFCs. Do people know what RFCs are? Do we have? Okay, so request for, okay, excellent, good, I was getting worried. Okay, so I'm glad people still actually read RFCs. So the fact of the matter is anyone, including you, could sit down and look at something, I know, for example, Tor's looking at this and say, I could create an informational RFC and suggest this. And then you can also say, I would create an informational RFC. And I actually think there should be a standard, and then it goes through this process of widespread open review, eventually gets up to the Internet Architecture Board. This takes a few years. It gives a quite thorough review, and they either approve it or deny it. And the web, often people ask, what is the relationship between the World Wide Web Consortium and the Internet? Well, the web is an application that runs on top of the Internet. Right? So the internet, of course, as everyone here probably knows, existed way before the web, and that the web may not last. We don't know. But the fact of the matter is, when the web started getting really big, a lot of large companies, large players started getting involved with the IETF, and the IETF is a much more loose and formal process. And so basically, Tim Berners-Lee, in order to sort of defend the open web from being taken over by a single company, I believe the problems at the time were Netscape and Microsoft, basically sort of said, hey, we're going to create a standards body, which is a consortium, which is more structured than the IETF, and which will handle just the web-facing layers. And that's the World Wide Web Consortium. Now, why a consortium? That sounds very exclusionary. Well, so the word open, everyone throws around all the time, open source, open standards. What does open mean? The W3C actually has a pretty good definition of open, which comes from the fact that it's a consortium. So even if you're making open source, you are possibly liable for licensing fees from software patents. The US software patent system is completely broken and is exceptionally rife with crazy software patents. So effectively, by making a consortium of most of the large companies, we're currently running 300 some companies, including most of Silicon Valley, IBM, Google, et cetera, and the newer ones like Facebook and Twitter, all of those patents are gathered together, and they make what is effectively a large patent war chest. And so if you say, hey, I'm a patent troll, and I have a patent on HTML, I have a patent on crypto and JavaScript, or what can happen is that W3C can sort of say, actually, we have a giant patent war chest of patent commits from major companies to HTML, And if you want to go up against us and IBM's lawyers and Google's lawyers, go for it, buddy. And that actually basically provides a large amount of safety for ordinary developers. So that's the important connection between open standards and open source. That while open source effectively deals, on the level of the source code, we, with specifications, deal on the level of the software process. The more abstract level can be implemented in open source, can be implemented in proprietary code, and the consortium has its structure to defend against patents. However, the consortium is open for all sorts of participation. You usually have to email the working group chair, the invited expert, and they will basically give you status of what's called an invited expert. So I think a question is, with the World Web Consortium, is we basically start working groups. And how many people here participate in a W3C working group? Okay, one. Excellent. Okay, so, well, it's better than IETF. I don't know. So the W3C, basically, how we work and how we make standards is effectively mailing list, IRC, and depending on how your working group goes, telecons and bug tracking. A huge Bugzilla list. And so effectively, if you can participate in any of those mediums, and you can actually track the often quite heavy amount of conversation going on, it's very easy to get involved. And the W3C starts working groups in particular places which we view as crucial to the future of the web. So, for many years, there was this excitement around XML, a lot of work, of course, going on in graphics. And where the web has perhaps been weakest is, as everyone here, I would assume, is intimately familiar with, web security. And that's what we're trying to fix. So another difference is that the RFCs are all in ASCII, while the W3C uses HTML, because obviously the web may not be around. But one of the concerns we have in standards bodies is that as long as there's only a very small number of people sort of really involved in these sort of voluntary processes, and often people are paid by their employers to be involved, it's actually quite easy, or at least, let's say, plausible to manipulate the process. So we know that Project Bull Run had a segment of it was to actually influence standards bodies to produce standards which were more amenable to whatever the NSA's goals were. And this had a very large budget, $250 million. The W3C's whole operating budget is, I think, around $10 million. So it's actually very small, so they could have just bought us, I guess. But they didn't. And while we don't have any evidence that the W3C itself has been manipulated, there's been a lot of controversy going on in the IETF with one of the co-chairs of the International Cryptographic Research Forum. Well, he worked for the NSA, and this has, of course, been called out and discussed, and he's still the co-chair, but, it's by Trevor Perrin, among others. We do have a number of places where we have good evidence, not 100% solid, but solid enough that you should be suspicious that backdoors have possibly been put in at least the pseudo-random number generators recommended by NIST, and that NIST, the National Institute for Standards in the U.S., because it does have heavy cryptographic expertise, does often recommend the parameters, and we'll go into this with web crypto in a second, used by various algorithms. And this is becoming much more earlier, because America was viewed as essentially having a sort of benign and neglectful role towards internet governance. And NIST, the problem with NIST had sort of both an offensive and defensive sort of rules. So sometimes, you want good security standards internally, and you want enemies to have weak ones. And so therefore, people sort of had I would say, more trust in NIST than they had before, after the Snowden revelations. I think Snowden revelations did reveal that the NSA was manipulating NIST in some circumstances, and now there's been recommendations from the White House, amongst others, to get that back in order. It's still a concern, and the question is, how do you detect that? Well, you detect that via open processes where you have lots of people involved, because the more people look at something, the more likely you are to discover the back door. If you're basically cooking up your standard, being in a closed industry consortium, no one will know if NIST or anyone else has manipulated your crypto. So what's been happening, which has been sort of interesting, is post Snowden revelations, there was a lot of outcry by the engineers. So most of these standards bodies are not ran by particularly I would say, high-level types, the most participation comes from people who are implementers, or I would say at least engineers with a high interest implementation in various organizations. And most people were quite shocked when the Snowden revelations came out. Tim Berners-Lee, the director of the Web Consortium and inventor of the web, basically said that he felt that Snowden, is a hero, should be protected, and that there was generally a lot of internal reviews started happening, looking at what standards that we produce where they could have been influenced, and that the most important thing is that for all future standards, the Internet Engineering Task Force has basically decided that they should be pervasive surveillance, which is some sort of global passive adversary, which can basically monitor all ends of the communication network, should be taken as a serious consideration. So just as we have in most IETF standards security and privacy considerations, we should have considerations around pervasive surveillance. And if you're interested in this discussion, the IETF has a discussion at PairPass, which is a pervasive surveillance mailing list, and there's a lot of other discussion going on. But I'm going to give you more about what the W3C is doing, because that's who I work for. And the Internet Engineering Task Force has been very upfront, and W3C is still sort of working on our game plan for this area. So we did host a workshop in March, which you can look at if you want to know what we're thinking about. We write and make public all of our logs. And we were sort of saying, well, what can we as W3C do to basically help combat pervasive surveillance? And there's a lot of problems. So some of them are outside of our control. One of the larger problems, of course, is the problem of certificates, right? So, certificate management, certificates, basically, if there is not a hard fail for certificates, the certificate system has this ridiculous attack surface, which can be easily compromised. And a lot of that's out of our control. That's in the hands of private, closed industrial consortiums like the Certificate Browser CA Forum. But at the same point, there are some things we thought for new standards which should be taken into account. So previously, in general, we have not taken into account data minimization principles. We have not taken into account ever traffic analysis. And of course, although the situation is pretty despairing right now around browser fingerprinting, we are trying to at least take these into account in future standards. And there are large amounts of problems, which I won't go through in detail, but effectively the web security model is well known to be broken. Very simple things like parsing URIs across various web browsers are not completely standardized and often prevent very interesting attack surfaces. So there's tons of stuff going on. I list quite a few of them there in all sorts of different working groups, but I'm going to concentrate on the ones that I'm working in. So the working group that I'm most involved with and helped start was the web cryptography working group. So we noticed the sort of disturbing phenomenon where effectively a lot of people wanted to do crypto in JavaScript. And they were really often very well-meaning people. And the fact of the matter is that it's in general, particularly a few years ago, a very bad idea. It's still often a bad idea, but we're getting a little bit better at it. At least we understand the problem and have some good things we can offer you, although not enough. So effectively, the issue is, even if I want to do any crypto in JavaScript, I basically have to call some server-side library. I have to often retrieve that library from another server. You basically have to trust whatever that code is. That code often has not been very well reviewed. So you look at openpgp.js, and well-meaning web developers. This came up with, I believe, CryptoCat, and has come up much more recently with Proton Mail, and was even, strangely enough, mentioned by Ladar in Darkmail. There's this real desire to do things like provide end-to-end encryption in JavaScript, which is, at least without a browser plugin, a terrible idea. It just does not work because you cannot basically buffer the private key from the server. And furthermore, your cryptographic routines, they're not necessarily well verified. They're not constant time. There's all sorts of problems there. And so we basically don't want people to create, and I can't tell if it's advertising or just idiocy, something like Proton Mail, which basically claims to be an end-to-end encrypted email service, which actually isn't, because it just runs in the browser runtime where you can't do that for very principled reasons. We would eventually like to get to the point where that is possible, but that's a long road. I'm going to walk through what progress we've made and what progress we haven't. So what we did is we did create a JavaScript web cryptography API. Just Google if you want to look at the API. And the API offers all the features that one would want out of effectively JavaScript web crypto. However, it is, so basically it's asynchronous, which is great. So it uses promises, which allows, so what you don't want when you're running JavaScript web crypto is you don't want to start generating a key and that jam up all the rest of your JavaScript code. It does offer probably too many cryptographic primitives. There's a bit of debate over this, but we do encryption, decryption, ECC, RSA, all of the classic stuff, all the hashes that you could, hash functions that you could possibly want, including ones that people don't like, and some of which are clearly broken, like SHA-1. But we do give all those to you, and we do want them to be sort of constant time. The problem is we do not, we realize that this API effectively is going to be used, we think, at least in this version, by people who are basically trying to code up some sort of protocol, and they can follow the instructions, and they understand their security models. What we're not trying to create in this version of the API is an API for developers who don't know what they're doing, who just want some quick level of security. We would like to do that. The problem is that's very protocol specific, so we said we're going to create the most general purpose one we can in the beginning, and more higher level abstract ones could be created afterwards by essentially at first polyfilling and later building on top in a more cohesive way and maybe a second version of the spec. So that's called the high level API. But we have a number of open issues. So one of the open issues is, so how the W3C works is we create a draft spec with the implementers involved, with a larger crowd involved. And the WebCrypt API had about, originally about 50 people in the room, and it's kind of died down a bit. But right now we do have all the major browser vendors involved. And one thing that the developers want is the developers want Bernstein's ECC curve. So curve 25519 is considered, more trustworthy than the NIST provided parameters for ECDSA. And this has been very controversial. It's actually still an open issue within the working group. Most of the browser vendors feel like providing this curve is a bad idea, mainly because it's unclear if that curve can be, so right now DGB says, well, of course it's a great curve. But there's, of course, the Certicom patent concerns, and also there's the fact that while DJB will provide in libsodium some very good code, the fact of the matter is, can you replicate that code across multiple environments? Is it well specified enough? And there isn't an IETF RFC for DJB's code yet. I mean, hopefully there will be shortly. And then if you're going to open up the door to different ECC curve parameters, why don't you open up the door to all sorts of possible curves? And if you do that, what else can you do? And this is where effectively Brian Lamacchia and other folks at Microsoft have been suggesting a new set of curves called the nothing up my sleeve curves. And these curves have been, and they already have them in Windows. They're available in the web next generation cryptography API from Microsoft. And should you expose those to the browser? So these are sort of issues that we have in a working group. What kind of algorithms with what parameters should we let into the API? And we have to balance that with the very real implementation concerns, right? So we don't have DJB's curve in NSS, which is the sort of baseline code which everyone uses for all of their crypto in their browsers, at least if you're cross-platform, such as Chrome and Mozilla. Other browsers, of course, call, like Apple and Windows, call it underlying OS code. So that's one open issue. Another open issue is the sort of broken crypto issue. So we do give developers possibly enough crypto to shoot themselves in the foot with. Now the reason why we do this is that we do believe that people will want some level of backwards compatibility when trying to do very well-known protocols, SSH for example. using the crypto API. And we do believe the crypto API is not just going to be used in browsers, but will be a sort of standard API across all sorts of native JavaScript environments. So of course, we have SHA-1 in there, which is broken. We did remove PKCS 1.15 because we do not authenticate, force authentication. We do not force initialization of vector randomization. We do not, and we have a lot of algorithms there which of course don't have security proofs, and some of them, some of the password-based key derivation functions have known weaknesses. At the same point, if we feel that they are well specified and enough people want them, we are currently adding them in, and we're trying to figure out how to make it extensible. We do feel like crypto agility could be a good thing, and this is a discussion I'd like to have with people here, but we don't want to try to force people to use what we think is good crypto, and later we discover it's not. So we're trying to be non-judgmental, would maybe one way to put it. Now, maybe the hardest problem, which we do not tackle, is key storage, right? So what a lot of people want to do is they want to basically do end-to-end encryption with some kind of long-term private key material. That private key material is hidden from the server. So we try to do the best we can. Currently, the best the Web Crypto API does is it basically does not pass around the raw key material. It passes around only handlers or identifiers the key material. And keys can be marked as either extractable, as in I can extract them from and get the raw key material and ship it around, or not. So we say, well, look, we can make keys which we say shouldn't be extracted, and we can also define an array of usages, such as encrypt, decrypt. So you don't want to reuse keys for things, often destroys whatever security properties they have. And we often, and this is what we try to do. But there is some just fundamental problems with the web security model. So right now, we cannot guarantee that those key usages you gave for encryption and decryption and signing actually are attached to that key material forever. So it can be removed and changed by JS code, either from the server or from the user side. And we don't preserve those via inside of key wrapping and unwrapping operations. And furthermore, we only offer ephemeral keys. The keys are bound to the session. And some of that was on purpose. So there was a concern that effectively if we created another magical key storage mechanism without thinking it through very hard for long-term key materials, we would just be creating super cookies. And we don't really want more super cookies than we already have. We're trying, and this is very different from the encrypted media extensions, DRM, effectively, which is being pushed through HTML5, not my working group, and W3C, where we're basically saying the key material should remain under user control. So the user should be able to delete keys whenever they want, and they shouldn't be forced to, there shouldn't be any key material which is hidden from them in particular. And so trying to figure out how you get key storage working in that paradigm ended up being a very hard problem. At the same point, there's a lot of good usages for having that, and we will return to those. And the last thing, which we notice is also